Complements in Venn diagrams, Introduction. So far, we've been building our understanding of sets, groups of things, and how they interact. We looked at finding what element sets have in common, that's intersection, and combining all the elements from different sets, that's union. Now, we're going to take that knowledge a step further and introduce a new idea called complements. We'll be looking at complements specifically within our Venn diagrams, which, as you remember, help us visualize these sets. So, what is a complement? Well, imagine you have a set, let's say set A. The complement of that set, A, contains everything that is not in set A, but importantly, it's still within the bigger picture, what we call the universal set. Think of the universal set as the entire world we're considering, and set A is just a part of that world. The complement is everything outside of that part, but still inside the world. Finally, it's important to understand why we're learning this. Complements aren't just a new concept to memorize. They're a really important tool for tackling more challenging problems involving sets. Being comfortable with complements will unlock your ability to solve a wider range of math problems, so pay close attention. Defining the complement. So now that we've introduced the idea of complements in the last slide, let's get a bit more precise with the definition. Here, we're going to formally define what the complement of a set actually is. We start by saying, let's represent our universal set, remember, that's everything we're considering as U. And within that universal set, we have a specific set, which we'll call A. Now, the complement of set A, and this is important notation, is written as a prime. We say a prime. It represents all the elements that are in our universal set, U, but are not in set A. Think of it as everything that's outside of A, but still within our overall boundaries. We can express this mathematically. It looks a little complex at first, but let's break it down. We write a prime equals the set of all x, such that x is an element of U and x is not an element of A. Voiceover, let me say that again, a bit slower. It reads as, a prime equals the set of all x, where x belongs to U and x does not belong to A. Voiceover. What this means is, we're defining a prime as a collection of all the x values that satisfy two conditions. First, they must be found within the universal set U, and second, they must not be found within set A. To put it in even simpler terms, and to connect it to what we discussed earlier about Venn diagrams, a prime contains everything inside our box. That's the universal set, except for whatever is inside the circle representing set A. Voiceover. This is a crucial definition, and we'll be using it a lot as we move forward, especially when we start looking at more complex Venn diagrams with multiple sets. So, make sure you understand this concept of a prime. It's the foundation for everything else we'll be doing with complements. Representing complements in Venn diagrams. So now that we understand what a complement is, everything in the universal set that isn't in our set A, let's look at how to represent it visually using Venn diagrams. This is where things really click, so pay close attention. This slide shows us exactly how to do that. The first line tells us the key idea. We represent the complement of a set in a Venn diagram by shading or coloring the region outside the circle representing that set, but inside the rectangle representing the universal set. Remember, the rectangle is crucial. It defines the boundaries of everything we're considering. We're not just looking at what's not in the circle, but what's not in the circle within our defined universe. Now, let's walk through a step-by-step example. First, draw the universal set. This means we begin by drawing a rectangle. Think of this rectangle as a container holding everything we're interested in for this particular problem. We call this container our universal set, and we label it U. Next, draw the set. Inside that rectangle, we draw a circle. This circle represents our specific set, which we've been calling A. This circle contains all the elements that are in set A. Now comes the important part. Identify the complement. The complement of A, which we write as a prime, consists of all the area that is within the rectangle, our universal set, but outside the circle A, it's everything in the big box that isn't inside the smaller circle. Finally, shade or color the complement. This is where we make it visually clear. we shade or color the area outside the circle A and inside the rectangle. This shaded area is the visual representation of a prime. The complement of A, it shows us all the elements that belong to the universal set, but not to set A. This is a fundamental skill, and we'll be building on it as we move forward, especially when we start looking at complements with multiple sets. So, make sure you're comfortable with these steps before we proceed. We'll be using this technique repeatedly, so practice drawing these diagrams until it becomes second nature. Example 1. Let's move on to an example to solidify our understanding of complements. This slide presents a relatable scenario. It states, let U be the set of all students in a class, and let A be the set of students who like pizza. So, imagine a classroom. Everyone in that classroom makes up our universal set, which we're calling U. And within that classroom, we're interested in the students who enjoy pizza. We're designating that group as set A. Now, the next line is key. The complement of A, denoted as a prime, would be the set of students who do not like pizza. Remember from the previous slides, a prime, that's how we write the complement of A, represents everything not in set A, but still within our universal set, U. So, a prime would be all the students in the class who aren't fans of pizza. Finally, this slide explains how this looks in a Venn diagram. In a Venn diagram, the rectangle would represent all students, the circle A would represent those who like pizza, and the shaded area outside the circle, but inside the rectangle, would represent those who do not like pizza. Visualize it. The rectangle is the entire class, the circle inside represents the pizza lovers, and the area of the rectangle outside the circle. That's where we'd shade to show the students who don't like pizza. This is a straightforward example, but it's important because it connects the abstract idea of a complement to a real-world situation. This will become even more useful as we move on to more complex problems involving multiple sets, which we'll explore in the following slides. Remember, the key is always to clearly define your universal set and then identify what's not in the set you're considering. Example 2. Let's move on to another example to solidify our understanding of complements. This one involves actual numbers, which can sometimes make it a bit clearer. Here, we're defining our universal set, which we're denoting as U. It represents all the integers, that is, whole numbers from 1 to 10. So, U is equal to the set containing 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Remember, the universal set is everything we're considering in this particular problem. Now, within this universal set, we're defining a specific set called A. A represents the set of all even numbers within our universal set U. So, A is equal to the set containing 2, 4, 6, 8, and 10. Next, we want to find the complement of A, which we write as a prime. As we discussed earlier, the complement contains everything in the universal set U that is not in set A. So, if A contains the even numbers, a prime will contain the odd numbers. Therefore, a prime is equal to the set containing 1, 3, 5, 7, and 9. Finally, let's visualize this with a Venn diagram. You would draw a rectangle to represent the universal set U, including all numbers from 1 to 10. Inside that rectangle, you draw a circle to represent set A, and that circle would contain the even numbers, 2, 4, 6, 8, and 10. The complement, a prime, would be represented by the area outside the circle A, but inside the rectangle U. This shaded area would visually show the odd numbers, 1, 3, 5, 7, and 9. This example helps us see how the concept of complements applies to concrete sets of numbers. In the next slide, we'll extend this idea to scenarios with more than one set, so make sure you've got a good grasp of this before we move on. Complements with multiple sets. So we've been looking at complements, everything not in a set, but within our universal set. Now, let's see how this idea expands when we have more than one set involved. This slide tells us that the concept of complements isn't limited to just a single set. It works perfectly well with multiple sets too. Let's say we have two sets, we'll call them A and B, both existing within our universal set U, remember. That's our big rectangle containing everything we're considering. Now, what if we want to find the complement of the union of A and B? That's written as a union B, with a prime symbol on top. We would say that as a union B prime. What does that mean? Well, a union B represents all the elements that are in either A or B or both. So the complement of that, a union B prime, represents everything in our universal set, U, that is not in A and not in B in a Venn diagram. This would be the area that lies outside both circles, circle A and circle B, but still inside the rectangle representing U. Now let's look at the other side of things. What if we want to find the complement of the intersection of A and B? That's written as a intersection B, with a prime symbol on top. We would say that as a intersection B prime. Remember, a intersection B represents all the elements that are in both A and B, the overlapping part of the circles. Therefore, the complement of that, a intersection B prime, represents all the elements in U that are not in both A and B. This means everything outside the overlapping region of the two circles, but still inside the rectangle representing U. This builds nicely on what we've already learned. In the next slide, we'll recap the key takeaways from this whole section, so make sure you've got a good grasp of these ideas before we move on. Key takeaways. Firstly, remember that the complement of a set, and we denote this as a prime, where A is just the name of our set, contains all the elements that are found within our universal set, U, but are not present in set A. So, if we have a universal set defining everything we're considering, and a specific set, A, within it, the complement is everything outside of A, but still inside our overall boundaries. Secondly, visually, in a Venn diagram, we represent this complement by shading or coloring the region that lies outside the circle representing set A, but crucially, inside the rectangle that represents the universal set U. Don't forget that rectangle. It defines the total scope of everything we're looking at. Finally, and this is important as we start looking at more complicated diagrams, the idea of complements isn't limited to just one set. The concept applies perfectly well when you have multiple sets. It allows us to represent, visually and mathematically, all the elements that are not in any of the sets we're considering. This will be particularly useful when we start looking at the complements of unions and intersections, which we'll cover shortly. Let's recap what we've learned about complements. This slide summarizes the key takeaways, and it's important you have these firmly in your mind before we move on to slightly more complex scenarios in the next slides. So, to reiterate, a prime is everything in U that isn't in A. We show it by shading outside the circle but inside the rectangle, and it works with multiple sets too. Make sure you understand these points, as they're the foundation for solving more challenging problems involving Venn diagrams and set theory. Common mistakes. First, a very frequent error is forgetting the universal set. What happens is, students get focused on just shading the area outside the circle representing a set, but they don't remember to keep that shading within the rectangle that represents the entire universal set. Remember, when we talk about the complement of a set, we're not talking about everything in existence, we're talking about everything within our defined universal set that isn't in the specific set we're looking at. So always make sure your shading stays inside that rectangle. Next, it's easy to get confused between complements and the operations of intersection and union. Think about it this way. Intersection and union are about finding elements that are in the sets, either in both or in either one. But a complement is about finding elements that are not in the set. So, if we're talking about set A, the intersection finds what's inside A along with another set. The union finds everything inside either or another set, and the complement finds everything outside A, but still within the universal set. Keep that distinction clear in your mind. Finally, incorrectly applying the concept to multiple sets is another common issue. When you have two or more sets inside the universal set, and you're asked to find, for example, the complement of the union of those sets, it's crucial to remember what that means. The union combines all the elements from both sets, and then the complement takes everything not in that combined area. So, you need to identify the area outside both circles, but still inside the rectangle. It's about finding elements that are in neither of the sets. Let's wrap up our discussion on complements with a look at some common mistakes students make. This is really important, because recognizing these pitfalls will help you solidify your understanding and avoid losing marks on tests. So, keep these 3 points in mind as you practice, and you'll be well on your way to mastering complements in Venn diagrams. Now that we've covered the common mistakes, you have a solid foundation for tackling more complex problems involving sets and their relationships.